2. Part 2 says to rent a moving van for a day, a company charges $10 and an additional dollar for each mile driven. Is this relationship uh, between the miles driven and the total cost proportional? All right. So let me actually erase that. So how should we do this? So there's a total cost, right? And we call that the y, or the y. I'll put that in parentheses. And then they said find the relationship between the miles that you drive and x. Let's put some numbers. Let's put 0. Let's put, I mean, I know you are not going to drive 1 mile, but let's say 5 miles, 20 miles. Let's stick those numbers. All right. So let's try to figure this out. So you go to the van, to the rental company, and you say, "Hey, I'd like to rent a van." Sign all the contract, and they say, "Hey, it's $10 for the day, and then every mile that you drive is $1." So let's say you rent it, right? You got the keys in your hand, and you go outside the parking lot. You are about to drive it out, and you get a phone call that says, "Hey, you know what? We don't need a van anymore." How much did you pay? Well, you still pay $10, right? You still pay $10. Scenario 2. Now you rented the car. You got into the car, and let's say your house is really next to the rental car company, right? You drove it because you had to carry a big furniture from your house to your mom's house, who lives 2 blocks away. So everything is within that distance. So you pay $10 for the car. Plus you drove 1 mile, and every mile is $1, so you end up paying 11. Okay. You drove it for 5 miles. Different scenarios now. So you gave the car company $10 just to get the car, and then you drove it for 5 miles. So each mile is $1. So you did 5 times 1, right? Because there's 5 miles, and every mile is $1. So you end up paying 10. 5 times 1 is 5, and you end up paying 15. You rented the car, so again you pay the $10. Now you're in the car and you drove it around for 20 miles. So the $10, so think of it as that plus 10, right? So it's whatever you drive around, however long, however far you drive it around, and then plus $10. So you drove it for 20 miles. Every mile is $1, so 20 times 1 is 20. So because you drove 20 miles, you paid $20 plus a $10 rental, it's 30. Right, so now we have a table to look at and start thinking whether this is proportional or not. Well, first hint that it's not proportional is that when you drove 0 miles, you still paid $10. So that's number 1, right? That tells you it's not proportional. Number 2, let's check for constant proportionality. Well, let's check over here. 1 times 11 is 11, so this should be times 11, and this should be times 11. Same constant proportionality, right? There should be the same ratio between the total cost and the miles. Well, 5 times 11 is definitely not 15, so it fails here. 20 times 11 is not 30, fails here. So that all the other pairs here, all the relations between the x and y are not with the same constant proportionality. So therefore, we can say that this is not proportional. Now, I'm going to take one step further. How would you write this equation? Well, how would you, right? So the question is, and this is how I'd like you to think, for us to find the total cost, to find the total cost, what do I have to do? Right, so if you rent a car, and let's say you drove for 12 miles, what would you have to do to find the total cost? Well, I know I'm going to have to take 12 and multiply by 1 because every mile is 1. And then what else do I have to do? There is a plus, and the plus what? $10 for the rental. So if I actually change this, right, total cost, it's going to be the number of miles times, how much is each mile? Times 1, and then plus 10. So my equation looks like this. Okay, y equals 1 times x, right, plus 10. You don't have to write the 1, but just to show you that every mile is $1. $1 times the number of miles plus $10 that you have to give the rental company. And notice, and what we talk about in class, equations that are proportional should come like this. Y equals k times x, and don't forget there is a plus 0, and we'll talk about that plus 0 later and how that relates to its location on a graph. That's 11. 12. Does the equation y equals x over 10 represent a proportional relationship? Well, if your equations come like this, right, where y is the constant proportionality times x, right, then it's in the format that represents a proportional relationship. But what about this guy here? That says y equals x over 10. In reality, that should be written as, well, if I, what is, oh, actually, maybe x over 10 is the same thing as x divided by 10, right? So go back to 6th grade when we change that to multiplication. So x divided by 10, which is what's written here, is the same thing as x times the reciprocal oh no. Oh. All right, so let's look at the next question. It says y equals fx over 10. And what they're asking is if this equation is in the format of an equation that represents a proportional relationship. Remember that equation that represents a proportional relationship looks like this. Y equals kx. Let me give you some examples. Y equals 3x. Every apple I buy is $3. I buy one apple, 3 times 1. I buy 2 apples, 3 times 2. I buy 5 apples, 3 times 5. Right? This is the price per apple. Right? I go to work and I get paid $3 an hour. I work 1 hour. How much do I get paid? Well, 3 times 1. Right? Because x represents the hours. If I work 10 hours, 3 times 10. Right? So that's my constant proportionality. X is the number of hours I'm working, and y represents the total that I'm going to take home. So if it's in that format, it's an equation that represents a proportional relationship. But look at this one. Does this equation look like that? It does, because y equals, and x over 10 can actually be rewritten as 1 over 10 times x. Now if you look at this, right, we have a constant proportionality here. Let me shade it. Oops. Right? There's your constant proportionality times x. So is this in that format? Yes, it is. So does that represent a equation that represents a proportional relationship? Yes, it is. All right. 13. Select all the information that lets you know that there is a proportional relationship between time and rainfall. Okay. Let's talk about this. Time and amount of rainfall. Right? There are my two categories. So there's a so it rains for, I don't know, 3 hours. We get 4 inches. I'm making this up. 4 inches of water, of rainfall. 6 hours, obviously double, 8 inches, and so forth and so forth. Right? So let's see if that helps us answer the question. The rainstorm lasted for 20 hours. Does that tell you that there is a relationship between time, and proportional relationship between time and rainfall? It tells me that the rain lasted for 20 hours, but it doesn't tell me how much rain it came every hour. I don't know. It could have been a lot of rain the first hour, and then little rain in the second hour, and then some medium rain the third hour, and then 11th hour, again, a lot of rain. It doesn't tell me if it was consistent rain. Right? There's that word, constant, I'm sorry. Rainfall, constant rainfall, something that tells me that it was steady, same amount of rainfall throughout the 20 hours. So I'm going to say no to that. B, there are 60 minutes in 1 hour. Okay, I know that. You know that. It doesn't tell me anything about the relationship between the amount of rain and the time that it rains. So I'm going to say no to that as well. Okay. Let's look for another one. 8.4 inches of rain fell during the storm. It's telling me that in total we got 8.4 inches, which is a huge amount, right? But it doesn't tell me how those 8.4 inches of water were spread out through the storm. What if he had most of it come up in the first couple hours and then little in the last 3 hours? I'm going to say no to that too. The rain fell at a constant rate of 0.42 inches per hour. Hey, we have a winner. What's the word here that I like? Constant. So every hour we got 0.42 inches of rain. We have a winner. The rainfall could be represented by the equation y equals 0.42x. Is that in this format? Right? Is your constant proportionality? Is this the unit rate? Is this the ratio that relates the y and the x? Yes, it is. Look. Right, so D and E are our winners. 14. A store sells peanuts by the pound. The equation C equals 0.8 times the number of pounds represents the cost in dollars. C and of a bag of peanuts that weighs P pounds. All right, so let's translate that into English or into a table. So C represents the cost. Here is the cost. Right now we know that cost should be the Y, what happens later, and before the pounds. And there is, look at the equation, a constant proportionality right here. All right, so we know that I can go already here and go color. I can go, hey, it's times 0.8, times 0.8, times 0.8. So let's put some numbers and also let's put that $1 where it belongs. So if I have 1 pound of peanut, 1 pound, and that's my unit rate, right? 1 pound. For every pound of peanut, I pay 80 cents. Right? That's what this statement is saying. Okay. So C is the cost, P is the pound, and 0.8 is the cost per pound, right? It's the amount of money you're going to pay per pound. What if I buy 2 pounds? Well, 2 pounds, each pound zero is 80 cents, so the total would be $1.60. Now the question here says, how many pounds did you buy if you paid $1? Well, let's put $1 here, right? So something, right? The weight of this bag of peanuts times 0.8 ended up being $1, and that's how much you paid at the register. So what was that number? Well, we can see that going this way, we multiply by 0.8. So reversing that, we're going to divide by 0.8. So take your calculator. My phone got wet today. So, we're going to go 1 divided by 0.8, and that's going to give us 1 pound, 1.25 pounds. So 1.25 pounds. Okay, 1.25 pounds. 1 pound, 1.25 pounds is the amount of peanuts that you bought, because that times 0.8 gives you $1. Okay. All right. 2 more. Tyrone's car can travel 30 miles for each gallon of gas. Okay. So write 2 different equations representing the relationship between the between the what? The distance and the gallons. Distance, gallons. So if I have 1 gallon of gas, I can go 30 miles. Everybody okay with that? So let me write gallons. And what is this? Distance. 1 gallon of gas, I can travel 30 miles. 2 gallons of gas, 60 miles. What's our constant proportionality? Right there, 30. That's our unit rate, right? And where's my unit rate? Right here. So 1 gallon for every gallon. I already wrote it here, but I'm writing it again. For every 1 gallon, I travel 60 miles. And what is it that we want? We want two equations. Okay, remember our constant proportionality and the reciprocal. So let me put x over here and y over here. The first equation is, how do I get y? How do I get y, which represents this? Find the distance that I can go. What do I have to do? Well, figure out how many gallons of gas you have in the car, right? So, what's the constant proportionality? 30. So, you're going to multiply 30 times the number of gas. So, if I have 1 gallon, 30 times 1 means I can go 30 miles. If I have 2 gallons, 30 times 2, etc. So, I'm multiplying all the x values by 2. Oh, sorry, by all the x values by 30. So, it's y equals 30x, which makes sense, right? To get these numbers here, let me put another one, 3 times 30 is 90. So to get this column, the y column, what do? I multiply 30 times the x values. What if we did it reverse? What if I told you I want to drive 30 miles? How many gallons do I need? I want to drive 60 miles. How many gallons do I need? So in this case, I'm asking you about x, the number of gallons. Oops, why is this not changing? Right, so this is saying, hey, how many gallons do I need? Right, how many gallons do I need? How many gallons do I need? That's what the equation starts. How many gallons do I need? If I have, right, so if I want to go 30 miles, how many gallons do I need? Well, in order to get this column right, in order to get x, remember we're going to go backwards the other way. So let me create another column over here. So let's continue that. And let's say I want to drive 150 miles. How many gallons would I need the distance? So if I wanted to find this column, the x column, right? So right now I want to find it. So if I want to find the number of gallons, what do I have to do? Well, I'm going to take 150 and multiply, right? Because we're going this way. I mean, I know we can say division, or we can multiply by what's the reciprocal of 30? 1 over 30. And then I would get the answer is 5. Meaning that to get x, I'm going to use the reciprocal of 30, which is 1 over 30, and multiply that by every y value. So you can compare this and this. Okay. So the first one is when you want to find the distance. Right? To find the distance, we're multiplying all the x values by 30. The second one is when you want to find the gallons. So to find the gallons, you're going to take the distance, right? In other words, the y, and multiply every one of them by the constant proportionality, but this time around it's the reciprocal of 30, which is 1 over 30. Okay, and that's that.